So welcome to today's lesson on alpha, beta and gamma decay. So in terms of the specification, only two learning objectives today, describing the effect of the atomic and mass numbers of a nucleus of the emission of each of the three main types of radiation, and then understanding how to complete nuclear equations. Okay, so we've looked at alpha and beta and gamma particles in the previous lesson. So as we know, alpha particles consist of these two protons and two neutrons. They're a helium nucleus, they're positively charged, and they are emitted from heavy elements when they undergo radioactive decay. Okay, things like uranium and thorium and plutonium. Okay, so there's an example there, the uranium decay of uranium-238. So you have uranium-238, it then decays down into thorium-234, and a alpha particle is released. Okay, and you'll note that the mass stays the same because 238 equals 234 plus 4, and the number of protons overall remains the same because 92 equals 90 plus 2. Okay, and you can also use the nomenclature of the helium nucleus if you wish to for an alpha particle. Then we have beta decay. Okay, so that's the loss of this high-speed electron. And they are emitted that when the isotope has too many neutrons, it wants to convert them into protons to stabilize the nucleus. And the proton remains in the nucleus. Okay, so the number of protons of the resulting atom increases, but you emit a beta particle. And an example there would be the decay of carbon-14. So carbon-14 decays. It forms nitrogen, because the proton number increases by 1, but also emits a beta particle. Okay, so again, the mass on one side of the equation equals the mass on the other side, because 14 plus 0 equals 14. And also the atomic numbers stay the same, because 7 plus minus 1 equals 6. Okay, so in terms of gamma decay, there is no mass loss or proton number loss, because it's just losing electromagnetic radiation. And that's just energy being lost from an unstable nucleus. Okay, so excess energy is lost in the form of gamma decay. Okay, and that is pretty much all you need to know for the different forms of alpha, beta, and gamma decay.